So, hello, Alex. Welcome to our virtual stage. So, for audience to know a little more about you, so Alex is the head of IEEE Blockchain Group. He also was recently featured in IEEE Blockchain podcast series. So, if you will go to blockchain.ieee.org, the first banner you will see will be the banner of our forum, which is thank you so much for Blockchain Technical Committee for supporting us. The second will be about technical briefs, and the third will be related to Alex podcast. The topic of podcast was it was related to his early theoretical research and how it relates to distributed ledger technologies and decentralized autonomous organizations, which is called DAOs. Alex, welcome to our virtual stage. I'm passing it over to you.
Thank you. And if you listen to this podcast, just one little disclaimer. I had my little boy tied to me, my little baby boy. So if you then hear occasionally some, baby sounds, that came from him, basically. Yeah, in any case. Yes, so I believe I have half an hour. That's correct, yes?
Yeah, absolutely. Yeah, that's correct.
So I have the slides ready. I will go to the slideshow.
Yeah, it is already on the screen.
Yes, and then, so.
Yep.
Okay. Wait, it's still loading?
Yeah, I suggest you to enable the slideshow. So basically,
Yes, I do. It's loading. Yes. Do you see the slide? Do you see it? Is it good now?
we see the browser right now, but it may work like this as well.
Okay, that's interesting. Because I went into screen share, and you don't see the screen share.
I got it. Basically, there is an option to use the Google Slides. So basically,
Yes, I did.
you select the presentation, and then you do
Okay. Let me do this.
slides, and then it
Yes.
plays them.
Okay. I'll go to here. Yes. Okay. So I stop the screen, I guess. Then I say present. I go to the slides. I go to Google Slides and then at the Google Slides, let's see. Okay, my slides don't show up. They don't show up.
They don't.
No. In any case, I can just do screen share.
Yeah, well, let's do screen share. Yeah, totally. Yeah.
Okay. Then I'll go back here. Recent.
You can also send me the presentation, and I can upload it for you if you wish.
That is also a good idea.
Yeah.
Let me just do a quick download then. Download. And how do I send them now to you quickly?
You can send it over to my email. Yeah, and I'm already opening it.
Okay, if you quickly type your email address, then I will shoot them over to you.
Yeah, one moment. Moment.
In the chat, I suppose you will share your email address.
It's actually my first and last name through the dot at IEEE.sergey.grivnyak.IEEE.org.
Probably I have it already.
Yeah.
Email address. So Sergey, recipient Sergey. Grubniak, yes, I have it.
Yeah, that's me.
Okay, Alex. slides. I will just attach them quickly. So. Okay, and they're on their way. Mhm. I thought I had done the upload somehow, but still sure it's not. You have an email?
No, not yet.
Yes. Well, I can start a little bit. So the presentation I want to talk about today is about the intersection of blockchain, Internet of Things, and security. Yeah, the presentation has several parts. So the plan is that I first go into the very basics about blockchain. So many presentations have already been conducted along this way. So there's not too much for me to say. I can cut some time there because I have too many slides actually. Then I want to talk about the Internet of Things and what the implications are. Certainly, with respect to the explosion of the amount of data that Internet of Things systems generate. And thirdly, I would then go into conceptual properties of security that one has to pay attention to, and how they then implicate the securing of IoT systems that we have ever more diffusing into society. Do you have the slides?
It is uploading. It is uploading.
Okay.
I think. Yeah.
So
I
if I
have.
go now to slides and Google Slides, then they should show up.
Yeah. Now adding to the stage.
Mhm.
Yeah. Is this correct?
Yeah, you are now showing them? Wait,
Yeah.
wait.
Now you are able to. You're
Here we go.
able.
Here we go. Yes, yes. Okay. And do I tell you then how to switch the pages or what the slides? Or
You can switch them
just
yourself.
myself?
Yeah.
No.
You can do it. Yeah. You just point here and point to the screen, and then there will be slide, next slide, etc. Do you have this option?
Okay.
If not, I will be doing
Yes.
it for you.
Okay. No, in any case, yeah, that's me, Alex Norta. I'm a member of IEEE Blockchain. I have also um, the leads of IEEE Blockchain Finland before it was for IEEE Blockchain Estonia. And I used to be an associate professor at Tallinn University of Technology at the Department of Software Science. And I also have my company Dimaxion, which I run. And I don't see any button to switch further. So if I just tell you, please the next slide. Yes. I think I have already done the introduction. So in addition, I would like to raise the point that this is all in the context of the so-called machine to everything economy, which I will briefly introduce. I think the rest I've already covered. Next slide, please. Yes. So if you want to find me, I'm on LinkedIn, and here's to the right the ETIS website, which is the Estonian Research Council website, where you will find my biography. I'm also on ResearchGate. Otherwise, you can just type in Alex Norta into search engine of your choice, and you will probably find a lot of material you don't even want to know about me. So it's very easy to track me down. Next slide. I'm also the editor of a special issue about blockchain technology and security in IoT networks. So the deadline for all the submissions. So as you can see here, that's a Q1 journal, impact factor 3.847. That's quite nice. Puts it into the Q1 category, and I'm very happy if more submissions could come in. Next slide. Yeah, so what's the motivation? It's the rise of the so-called machine to everything economy, M2X economy. Next slide. So here's a little paper that is a position paper actually that we published. Benjamin Lading was one of the was my master student, and I co-supervised him for his PhD student, and Priyanka Sharma was at his department in Clausthal in Germany. So we came up with this position paper extracted from the award-winning M2X economy PhD thesis of Benjamin. Yes, I would suggest it's very nice if you could read this paper that also justifies how blockchains and security fit into this M2X framework. So here's a bit of a lengthy definition at the bottom, but it's basically a system where you have interactions, transactions, collaborations, and business enactments among humans, autonomous and cooperative smart devices, software agents, and physical systems. So thereby an ecosystem emerges that's automated, globally available, a heterogeneous socio-technical e-governance system with loosely coupled peer-to-peer resembling network structures, and by its dynamic, continuously changing, interoperable, open and distributed nature, and typical manifestation of such an M2X economy as, for example, cyber physical systems or Internet of Things and wireless sensor networks. Next slide, please. Yes, so I already alluded to before that this presentation will discuss the intersection of IoT, blockchain, and security. Next slide. So first, a bit Internet of Things. Internet of Things that build a bridge between digital and physical world, ever more without human interaction. So what are the functionalities of IoT devices? They're smart sensor-laden devices that autonomously exchange data across the internet. They receive and transmit data to different devices and allow more than one device to be connected with each other to create real-time linkages. So this creates many new business opportunities and new market opportunities. At the moment, so 55 billion IoT devices are forecast to hit society by 2025 from 9 billion in 2017. So that's really a dramatic increase. Yeah. And so also the investment amount is very considerable then. So the forecast is between 2017 and 2025, which is not too far away, will be $15 trillion US or euros, is pretty much the same these days. And we potentially, so the selling point of IoT devices and systems is that they improve our lives. For example, the monitoring of health matters like blood pressure, blood sugar. Yeah, that's one example. Energy use optimization and much more. Next slide, please. So this raises, of course, many significant problems. Yeah, so we get the rosy picture of what is all being resolved thereby. Yeah, but these devices have many problems which are interesting for scientists and students to resolve, to make an impact on the market. We have, with this rise of the IoT devices, billions of transactions per device, which creates a lot of latency. We have lacking standards because these devices are produced by many different companies that don't agree on the standards. So that's where IEEE comes in very nicely, putting a lot of emphasis on industry standardization. IoT devices have low computing power and data storage, and there's also problems with good network connectivity. Also, when it comes to security and privacy, there are many problems. So if you know Amazon's Alexa, yeah, it's been blamed for spying on conversations. I have a little link here for entertainment that you can click on later. So I hope these slides are being shared with the audience. That would be very nice. Then it's possible to click on these slides on the hyperlinks to further information. Heart pacemakers, they can be hacked. Yeah, I've seen this personally with a cybersecurity student who did this very, very easily. Security cameras can be hacked, consequently also baby monitors. As a result, I mean, with these anecdotal examples, 2/3 of consumers think that IoT devices are creepy because you just can't trust them. Next slide. The other problem, which is particularly interesting also for researchers, is that the current RT system model is very much centralized. So it's a bit organized like a starfish topology. Mm. And so there's a cloud in the middle, yeah, and all the communication and control happens through the clouds to the IoT devices that are around it, yeah. And if IoT devices want to communicate through each other, to each other, it happens through these clouds. So yeah, the problem is connections can only be identified and verified through this cloud. There's a high maintenance cost with this type of construction. Extra infrastructure has to be added with best IoT solutions. And of course, if the number of IoT devices is interconnected at a time, the number of communication increases. And so there are economic scalability engineering issues. Yeah. And so if these issues go beyond a certain limit uh, with the cloud services, that leads to security issues. So if I'm a hacker, this is a honeypot. Yeah. So of course, I want to make sure I get into the cloud and then I can just um, take all the information out. So potentially the solution lies in a decentralized network. Next slide, please. And blockchain lends itself here, which, well, I guess I don't have to, given all the prior presentations and the audience, I don't have to say too much in this respect, but um, came up, of course, with Bitcoins and initially, so I got into this research very early, already in my old PhD thesis, before blockchains were around as we have them now, was very much about, you could say, in modern language, DAOs and smart contracts and how they collaborate across DAOs. Um, so not too long ago, if you wanted to get into this type of research, blockchains and so on, you were the drug dealer and the money launderer and the whatever strange stories they mentioned. But nowadays, we have, of course, much more acceptance, and the importance of blockchain technology in society has been acknowledged. So there's much more funding. There's a widespread industry adoption throughout so many sectors. And yeah, so the popularity is increasing dramatically. The use of blockchain in so many different areas. Banks, even legacy banks, are adopting blockchain technologies, and even on a EU level, there are very significant blockchain initiatives. So the point is that they're cryptographically secure, immutable distributed ledger technology, blockchains. And I would assume public-private key or concepts and so on, that's all known here. But maybe from a quality point of view, I mean, non-functional requirements, I would say immutable traceability is a key aspect that blockchains bring us. And as such, in society, blockchains can then function as some sort of trust engine, because once an event makes it on a blockchain, can't be undone anymore. So there you have traceability about events that have occurred. Next slide, please. Yeah, this paper is well known. I think in this audience, I don't have to go too much into it. It's the most famous Bitcoin paper. Next slide, please. Yeah, this is a screenshot taken out of the Bitcoin paper from Satoshi Nakamoto. It just shows that you have an, an arbitrary number of public keys, yeah, that can for transaction purpose, and your private key you basically should keep to yourself, yeah, and then you can sign off transactions versus the public key only into one direction, yeah. That gives you a pseudonymous, so to speak, a quasi-anonymous scenario for transacting and collaborating. In the meantime, we actually also have fully anonymous solutions, whether it's in the crypto token space or also on a smart contract level. This is very nice smart contract blockchain system called Dero.io, Dero. .io, that's fully private. I would say quite an improvement to, say, the pseudonymous smart contract blockchain systems. Next slide, please. Yes. So This goes further into the nature of decentralization of blockchain. So you have basically blocks that get in a decentralized way mined into existence, and so you get a chain of blocks, and this gets replicated out to nodes. And if a node gets corrupted or attacked or whatever, you can heal that just by synchronizing again with the other nodes. Thereby, you have a very robust system provided there enough participants to participate, say, maybe in proof of work riddle competitions. Also, in more in other systems, we have proof of stake to not have to expend all this computational power on solving the riddles. Next slide, please. Yeah, so proof of work, proof of stake, the difference probably is quite well known here. And so, yeah, is there anything new? I think I've mentioned all of this already. Next slide, please. Yeah, and so with versus the initial crypto token systems, what we have then coming up was the smart contracts. Basically, an extension of the protocol layer on top of the blockchain layer, with the most important system being Ethereum initially, and thereby you can kind of orchestrate transactions. Yeah, and this, of course, then is the foundation to very exciting decentralized application or DApp developments. Next slide, please. Yeah, so again, so the nice thing I would say about all this blockchain work is how open source it is. Yeah, and here's again the Ethereum white paper. Here it's actually mentioned that we have also decentralized autonomous organizations emerging with this type of technology. I would say this is a very hot topic for governance, so certainly for the Ukraine. I would say DAOs and blockchain-powered DAOs for e-governance should be something that hopefully will be looked at for the digital transformation. Next slide, please. And we have, in the meantime, a huge amount of different types of blockchains, smart contract blockchain systems. There's, of course, Ethereum with the first move advantage, fully public, where anyone can participate. And then on the other extreme, we have Hyperledger, which is permissioned, where you have to kind of knock on the door, allegorically speaking, to be let in. And then we have between those two extremes on the spectrum of being fully public or fully permissioned and private, we have systems, I mean, smart contract systems in between. In the meantime, we have really a huge amount of different smart contract blockchain systems. So if you go maybe a little bit into my ETIS research profile, you will see many papers that we've published. I mean, me together with my PhD students doing systematic literature reviews about the pros and cons of all these different smart contract blockchain systems. Anyone is interested? Next slide, please. So from a security point of view, then we have these very, very common aspects that we need to look at, certainly for securing IoT systems. That's confidentiality. So that means data is secured to authorized parties. Integrity. So that means that the data can be trusted, and availability, so that the data is accessible when and where needed. That's a so-called CIA model in security, which is very well known. In addition, with the adoption of blockchain technologies to achieve decentralization, yeah, going away from this honeypot scenario with the clouds in the middle governing all the devices, we can now also consider non-repudiation. So that is tied to, so that means service provides a trusted audit trail. Yeah, this is something you can clearly achieve through blockchains, because you simply store the events on chain, which are then immutably traceable. So this goes together clearly with non-repudiation. Then you have authenticity, so that means components can prove their identity. So in a most intuitive, obvious way, that's achieved very much through the public-private key mechanisms I alluded to earlier. Then we have also privacy. That means the service does not automatically see customer data. So, and that again ties in very much with public-private key infrastructure of blockchains. So, in other words, an entity, whether it's a human or non-human or an IoT device, can decide to whom data is being disclosed, yeah, in a quasi-sovereign way. Next slide, please. So let's now quickly delve into the intersection relating IoT data, blockchain, and security. Next slide. So what we see is that the IoT security budgets are exploding. By 2020, that we have seen an increase versus 2015 from 1% to 20%. So probably we're coming close to 30% pretty soon, yeah. And we have IoT bottlenecks and technical deficiencies. So the autonomous devices must be integrated into a larger IoT system infrastructure. They have virtual identities that create trust issues and authentication issues. Certainly, when we lack standardization, there's point-to-point communication. It's complex to coordinate and easy to attack. Yeah? And then there's the data integrity, which means it's potentially easy to compromise data, certainly when you interfere into an IoT system. So allegorically, we could say it's a bit like a castle with a wall. Yeah, and as long as the wall is up and intact, there's no problem. But if the enemy can take just one part of the wall down, then the enemy can just intrude and take over the city behind the walls. Yeah. And it's a bit here the same. So you have all these devices that are autonomous, and that should integrate with all the other devices. But if only at one point this is compromised, then you basically have this scenario where just one small part of the castle wall is down, and that's already good enough for the enemy to invade. Next slide, please. So there are many security threats like unauthorized physical device access, software attacks. um, you can have distributed denial of service attacks, impersonation, device spoofing, and so on. So the many opportunities to break into IoT devices. And to alleviate that, to mitigate that, we have solutions that are focused on identity management and encryption. And what is really needed is that we have kind of a life cycle understanding that should be established. Yeah? For IoT systems, a micro life cycle per device. A device is mounted into and integrated into an existing IoT device. Then there are communication channels changing. There may be updates, and at some point, a device is decommissioned and taken out. Yeah, so there's a kind of a micro life cycle, and then there's a macro life cycle for the entire IoT system that goes through epochs. It's initially set up, and then parts of the system are upgraded, certain device categories are replaced with more modern ones, and so on. Yeah, and eventually, maybe the entire IoT device itself is being taken down. So blockchains could mitigate, providing a framework with automated security and attack prevention. Next slide, please. Next slide, please. Hello. Hello, hello.
Yeah, which of the slides? This is slide 25. This is 26.
Yes.
Which one would you like? Next.
Yeah, the next one, yes, please.
Yeah, next.
So now it's crashing a bit.
This one.
I don't see now what's going on. Okay, what can I do? It seems. Oh yeah, okay. So something happened. I'm still here, but okay. So my browser disappeared, and I don't know where it went. Where am I? Mm-hmm. Interesting.
We lost Alex. Let's give him a moment to get to return to us, and then we continue. Oh yeah, Alex is with us.
Sorry, I don't know what happened. My call.
Yeah, Alex. Yeah, yes, you're back.
Go one slide back, and
Yeah.
and one back. Okay, yes. So to cut the long story short, because I think I'm already a bit over the time. So the point is that with blockchain technologies, how you can tackle this centralization problem. So on the one hand side, with blockchains, you achieve a bit of an adoption of a more standardized approach to treating security. You can also potentially achieve that blockchain technologies create a peer-to-peer scenario, yeah, between the devices to communicate, and the communication is also encrypted, and um, the idea is that you have a wallet, yeah, and a device can ask another device to set up a communication channel. And what happens there is that basically keys are exchanged to establish such an encrypted then communication channel. Everything is logged, yeah. So you can audit with timestamps, of course, on chain what's happening, and thereby very quickly determine if a security issue occurs, who's responsible for that. Next slide. So I worked on a solution for that a bit, also for the well, trust establishment. But maybe we can skip this about multi-factor challenge set self-sovereign identity authentication. Next slide, please. The idea is that for such complex systems, one key is not sufficient. Yeah, so just one public and private key is not sufficient. So instead, that you create challenge sets that are configurable depending on the context, and with that, you have a much more fine-tuned option if the challenges are issued and the responses are collected and evaluated. Everything goes on chain to then determine if the other device is really trustable. Next slide. Yes. What I still wanted to mention was there are problems also which are very very interesting for scientists. Potentially, blockchains resolve the issues of centralization and security, as pointed out, but of course, due to the limitations of IoT devices, it is not possible to store entire blockchains on a device. Yeah. Also, proof of concept is sorry, proof of work where you resolve very elaborate cryptographic riddles. That's also, of course, not an option for energy and capacity limited in general IoT devices. So instead, probably to not have to well require every device owning an issue of an entire blockchain, which can be many gigabytes. One option could be to work with shards. Yeah, so this means you have just elementary parts of a blockchain that get stored into a device so that it can operate, and these are then swapped out and replaced from the overall blockchain. And of course, very nice open issues. Then also the verification algorithms, validation algorithms of blockchains. So proof of work, as I said, is too time consuming. We already have latency issues. So other algorithms for that have to be considered. Next slide, please. So here, yeah, so this is just a list of other blockchain use cases. Maybe you just go through, if you just click and show, I have in the slides, which hopefully you can share with the audience, looked into papers. So if you just click through, just go through them, please. Next slide, and so on. That this is really happening, this type of research domain. So if anyone wants to get into this, maybe you have many students in the audience. Application cases like blockchains for energy management or smart city management, of course, e-healthcare, logistics like here, yeah, tracking, preventing counterfeit products. Next slide, please. Yeah, this is office-based management and blockchains towards a smart city kind of context. Next slide. Energy sector, I mentioned already. Next slides. Yes, and also this is a very vivid field to look into. If you just can click through, please, as I speak. Here's just the evidence. These are very current papers published precisely in this intersection: blockchain, IoT, and security. Just please, next slide. Next slide. Yes. Also for Web3, of course, this is very interesting. So this is really a very, very growing field of investigation, and I would encourage people in the audience to move into this space. So I think we can move to the conclusions, because I'm already 10 minutes almost over the time limit. If you click further to the...
Yeah. No worries about that. We have a later
Okay.
break, so this break
Ah,
was a little longer. So we
no, okay.
it's fine.
Yes. No, but you can go to the conclusion. Thank you. So
Yeah.
that's pretty much the last slides. I tried to really hurry up. Usually this takes me about an hour to present, but I think you still got the main points. So the main issue, just to summarize, is that we have IoT systems with centralized architectures, which are a single point of failure and a honeypot for hackers. Yeah, and they really create kind of a bottleneck scenario that doesn't scale for IoT systems. The conceptual security properties that exist are confidentiality, integrity, and availability. So that's the very traditionalistic cybersecurity CIA framework. But with the advent of blockchains that you can, in theory, adopt into this IoT space, you can then also work with notions of privacy, authentication, and non-repudiation. Yeah. Blockchain technology does present itself as an option for IoT systems that generate then really large data management problems. But we have these very interesting limitations, interesting for scientists, also engineers who like to experiment and adopt challenges. So the current performance and scalability of IoT are incompatible with blockchain functions and vice versa. So we need really new types of blockchains for IoT to connect these 55 billion IoT devices. And in fact, there are already IoT-oriented blockchain systems emerging out of research and development. So I've seen some papers in this direction. This is very encouraging. And we need novel consensus and validation algorithms. So I mentioned before, proof of work is not really a good option for capacity-limited IoT devices. Proof of stakes probably also problematic. So this is again very nice field for researchers to be very active. Yeah, so these IoT devices are a massive source of raw data that we generate, unspeakable amounts. And another point then that becomes very interesting is that we need to then figure out how to combine and understand this unstructured data. So here, once again, if we go to big data and machine learning and all of this stuff, a big problem of this is of these domains is where does data come from? Yeah, is it trustable? Yeah. So you can have the most amazing and most sophisticated machine learning algorithm and so on, but if it's garbage in, then it's of course garbage out. So in order to have trust in the data that you feed, in the quality and authenticity and so on of data that you feed into machine learning algorithms, again, blockchains are very good for what is called in English provenance tracking. In plain English, you need to then with the help of blockchains, where does data come from, and is it trustable data? Yeah, which is currently not the case. So we need to learn. So this is then a very interesting combination. The IoT systems, they create huge amounts of data. They themselves have to be secured, but then also for all the knowledge that we can generate out of these massive data sets that IoT systems generate, we need to also have trust in those data sets, where they come from. So that again makes it very clear we need really blockchains because of this immutable traceability quality feature or non-functional requirement that blockchains satisfy. And we can then extract certainly also with means of artificial intelligence. Yeah. Very, very strong, good knowledge. If we combine blockchains with AI, we get high quality knowledge, and then actually all this massive amount of data that the IoT systems now generate very explosively, as I hopefully have made clear in this presentation, that actually becomes workable, and it's something that hopefully will improve society. Thank you, and sorry for being a bit over time. Thank you so much. Are there any questions?
Yeah, that is a question. So it will be like a little bit of a high level question. So you mentioned many times the work with basically the distributed ledger technologies and specifically blockchains with IoT. And you mentioned multiple consensus algorithms fitting or not fitting the requirements.
Yeah.
Can you please provide your view on maybe high level regarding the what are the core requirements for distributed ledger technology to be a fit for IoT? Is it a light device, low hardware requirements? Is it is it basically a decentralization of the system, so many devices can have node setup, or is it like high scalability or something like that?
Definitely. Yes, I mean, definitely it's very high scalability. So, I mean, of course, it will help that the IoT devices themselves improve and achieve better capacity. But still, yeah, you need. I think what would make a lot of sense is to look very much into notions of sharding. Yeah, how
Okay.
can you efficiently manage shards that are then very dynamically onloaded and offloaded of devices as they need them on the go, so to speak, as they operate and communicate with other devices. And for that, maybe the current, maybe for that, so my colleagues in Tallinn, they're working on blockchain types that are very much tree structured. Yeah. So then, I mean, if you have a tree structure, then it becomes actually possible that you cut out a subtree, and that you add into, I mean, as a shard, so to speak, into a device. The device can even go off chain, and then in return, uh, if say IoT devices then work, maybe even in an off-chain setting for a certain amount of time with such a tree structured shard, then it can at some future point in time be onloaded again with the overall blockchain and synchronized. So I would say this is a very important aspect that should be looked into. Yes, and it must certainly be pretty much a lightweight solution. I mean, you can't just fork say the Bitcoin blockchain and expect that to be sufficient then for IoT solutions. Is completely impossible, of course. So, but as I said, I mean, there's a lot of good work happening in this direction. Yes, exactly. Q&A. Good work happening in this direction, and I would again encourage certainly students, PhD students, to move into this direction. Thank you.
Yeah, thank you for the response and the presentation. It was very insightful. And
And sorry for the crash of my Chrome.
no
Yes.
worries.
Yeah.
Technical issues always happen. So let me check if we have any other questions.
Mhm.
I think we don't. So Alex, thank you so much for being with us.
Thank
And
you,
yeah,
and good luck.
yeah, thank
Yeah.
you.
Thank
Uh,
you.
So yeah, we are yeah, and definitely. But at the end of this event, again, I highly recommend to go to blockchain.ieee.org. Wait until third banner will appear and to listen to podcast of Alex. So where he share,
Thank you.
yeah, other different aspects of his work and yeah, and many other interesting things. With that being said, we are welcoming on the stage our next speaker, which will be soon after the video. Thank you.
Okay. Yeah. Bye
Bye.
bye. Thank you.
Thank you.